Hi, everyone. My name is Kyle Sword,
And I'm Kayla Natividad.
and today we're going to be doing a quick presentation for you on anti-reflective glass. Got talking in our office, and a suggestion came up, said, hey, why don't we do some individual product presentations to really talk about it? We can use them for internal education and all that sort of stuff. A lot of times when we go talk to architects, we have to be very neutral about our products. We can't actually even mention any of our product names, so it's just education. So this is intended to be kind of a short and sweet highlight of our products, what they do, and how they work. I'm going to pull up a presentation here, and Kayla is going to try and help keep me honest. Like I said, I semi-understand these things, but Kayla actually is a good technical expert, so she'll at least help me if I'm missing it.
I'll try to.
All right, so today we're going to give you an overview on anti-reflective coatings. We're going to be talking primarily about our Pilkington OptiView, but there's a couple other things we want to share. Really, all we want to do is go over what is it, how's it work, how's this compare to some other options, where would you use this, what products do we have, and then we'll see if there's anything else that we need to cover. And so this is, typically what our anti-reflective coatings do is a standard piece of glass, a piece of clear glass has about 4% reflection off of the first surface. And on the back side of that piece of glass, you get about 4% reflection off of that. So a regular piece of clear glass gets about 8% reflectivity. Well, if we put a coating on there that's designed to be anti-reflective, you're actually reducing that 4% reflection down to less than 1%. And then if you actually laminate two pieces of anti-reflective coating together, which is typically how OptiView is sold, you get two coatings on the outside surfaces that are laminated less than 1%. So your overall reflectivity on that glass is less than 2%. It's about 1.5. The two inside faces, when they bump up against the PVB, there's no interface there, so you don't get a reflection off of that. So once you laminate this together, you get a really nice laminated, very low reflective product.
So it's something to note is it's a common misconception that they only need the anti-reflective on the two exterior surfaces. And so what we see often is people trying to put this into an IGU, where now you have two separate pieces of glass with an airspace between them. So not only are you getting the reflection from what would be surface 1 and surface 4, you're also getting the reflection from surface 2 and surface 3. So that there's a difference between having it on 1 and 4 in a laminate versus having it on 1 and 4 in an IGU. It's really so, and it's just more to highlight that optimal performance is in a laminated glazing, and it doesn't act the same if it were in a insulating glass unit.
Yeah, that's a great point, Kayla, because actually in an IGU, which typical construction is two pieces of glass with an airspace, you get 8% reflection off the outside light and 8% reflection off the inside light. So typically an IGU is at least 16% reflective. So like I said, if you think you put this in on surface 1 and 4 in an IGU, you're going to go really low. You're right, it doesn't, because you've got to have it on a laminate, or you have to have it on all 4 surfaces to really get that super low reflection.
Yeah.
Yeah, thanks, Kayla. And then, a lot of people kind of intermix these things, anti-reflective and anti-glare glass, and think, well, it's the same thing. Well, it's actually not. We make anti-reflective glass. And what this is we're getting what's called destructive interference. And David Strickler and the coating guys will give you a lot better information on this than I will. But what you're doing is you're taking all those multiple layers of coating that we make, and you're making where that reflection bounces off the glass, you're making that reflection kind of change its wavelength enough so that the wavelengths interfere with one another as they bounce off, and it actually kills the sound. So you're getting not only less reflection coming off the glass, you're actually boosting your light transmission that goes through the glass. And anti-glare, as a difference, what you're doing with anti-glare, a lot of times this is like an acid etched on the surface, and all you're doing is you're scattering the glass or scattering the light. So you still have all that reflection on the surface. You don't boost the light transmission, but you don't see glare and reflections off there because all it's doing is scattering across the surface. So typically, if you go to like a drive-through, like an ATM, and you get off angle and you can't read the screen, but when you're straight on at a 90 and you can read the screen, most times that's an anti-glare. So, there's reasons that you might want an anti-glare for privacy, or you really want to have that matte surface on there. But there's a lot of other times that you really want anti-reflective glass. So really, there's a difference between the two that you need to understand. The other thing I'm going to mention on this is, how do we get really, really low reflections? There's other coatings that we make. Ours is about 1.5%, but you can buy an anti-reflective that gets you down to less than 0.5%, really, really low reflections. The reason we don't make that is you can see this curve here. This is the OptiView. This is across the visible light spectrum. And across the visible light spectrum, you go from blue to all the colors of the rainbow over to red. But when you drive that reflection really, really, really low, you're having to select a material that's really low in the center. So it actually bumps up a little bit on the edges, and you can't keep it flat across the visible spectrum. What that means is you get a little bit of blue, you get a little bit of red, and the color of the coating actually looks purple, especially when you get it off an angle. So if you go see a lot of like fish finders, or if you're looking at like a workout screen that's on an elliptical or something like that, when its screen is off, it kind of looks purple. Well, that's the reason why. It's a really low reflective product, but it is when it gets really low, the trade-off is you get purple in color. We keep OptiView really, really flat across the visible spectrum because we want it color neutral because it's going into buildings. Anything I missed on that, Kayla?
No, the only thing I think is that a lot of times people think purple reflection is synonymous with anti-reflective. And so when they see the purple reflection, they think, oh, it's working. And
Gotcha.
I think one of the things that we want to do with especially OptiView and the color suppression is change that idea of purple doesn't mean anti-reflective. Purple just means a purple reflective color. So it's two different things, trying to make the customers really understand that what the color neutrality really means.
Yeah, excellent point. Good thought, Kayla. So, most times people are using anti-reflective, and I'll get into the products here in a little bit, but a lot of times it's going into signage, whether it's print signs or digital signs or a number of different things, or it's going into buildings for a number of different reasons. We want to reduce reflection. The killer on this is that if you just send somebody a piece of glass, you send them a piece of clear and you send them a piece of laminated anti-reflective, it doesn't look hugely different because your eye is not really trained to see that contrast from two pieces of glass that you're looking at. So if I have one building that's on this side of the street that's clear glass, another building on the other side of the street that's anti-reflective glass, you're probably not going to say, oh, there's a huge difference between those two. But you really see a difference in contrast. And that's what I'm showing you on this right side picture here. This is at a stadium, and the fabricator, instead of taking that lamination and putting the coating on surface 1 and 4, they accidentally flipped it and they put both coatings against the PVB. So what you're seeing here is all this press box area has anti-reflective glass in it. And this one just looks like a regular piece of clear because the coating was actually against the PVB. So you don't get that anti-reflective benefit. You can see here with this piece of glass, you can't see through it, and you're seeing quite a bit of the white sky behind. But where the anti-reflective glass is, you see the lights through there, you see chairs, you see people standing in there. There's a huge difference between the two. And the impact this has on the viewer is you actually see out, you see the game better. You don't see the reflection of your t-shirt or the lights behind you when you're in these press boxes. And you can also see into the press boxes really well. So if you have a car showroom and you want people to see the car as they walk by, anti-reflective glass really works, but people only notice it in contrast. The other kind of interesting thing on this project was they used it on the spandrel glass, which is the non-vision area of the building. And you can see this top right corner, they did the same thing as they had it flipped, and the regular piece of uncoated glass was on the outside. You see this huge difference in contrast, but you wouldn't notice it if it was just by itself. But the reason they did this was to keep the glare off of the spandrel glass from blinding the players on the field. And we have a couple different products. We make a product called Optar. Optar is non-color suppressed, so it's going to have that weird curve that kind of makes it a little bit purplish in color. But that goes into a lot of displays. I'm going to talk about it in just a minute, but we can make it on thinner glass. We can make that down to about 1.6 because we don't have to have those color suppression layers. We also have a product called Optar Plus. Optar Plus is similar to Optar in terms of performance and aesthetics, but it's fully dielectric. So what that means is you can use it with any sort of touch screen. The signal that comes from the coating won't mess up the touch functionality. So if people are putting in touch screens, they've got to use that Optar Plus. Regular Pilkington OptiView, we make this on clear, we make it on low iron. We're looking at making it on other products as well, but this is anywhere from 3 mil up to 12 mil. We can make it depending on the plant where it's being made. There's a product called OptiView Ultra. This is kind of new to North America. This is actually a sputtered product that's made over in Europe, and they do an anti-reflective on surface 1 and surface 2 of a piece of monolithic glass. So most times regular OptiView, to get a double side anti-reflective, we have to laminate it together, or our customers do. OptiView Ultra is different, where it's a single piece of glass that you can temper. It's got anti-reflective on both sides. That sometimes people really just want tempered glass. They don't want to have to laminate. There's other reasons that they might want it as well, for thickness or weight or profile or a number of other things, but that's a nice product. And then finally, we have a product called OptiView Fusion. This is our pyrolytic coating on one side, and then it's the sputtered coating on the other side. And there's reasons that people might want that as well, for durability, for color. Sometimes the color that you print on there is a little bit more true if you use this product. Anything I missed on the products, Kayla?
No, that was a great summary of our anti-reflective option.
All right, thanks. And there's, a number of our competitors make other similar products. I don't know a lot of them offhand. Luxar is one. There's a number of others, but they have the same thing. They have double-sided products. They have single-sided products that they laminate. But I would say most other products tend to have a little bit more color, and they tend to be more designed for applications that aren't as specific to architectural design. That's really where we kind of stand out. We make it on low iron glass, which is really desired by our architects. And we do a really nice job with color, and durability of our product, because it's pyrolytic, is really, really good on surface one. So that's the other thing we really tout, is for an exposed exterior surface, we really have a nice product for that. Optar, where's that get used? Again, a lot of times it's a single piece of glass that gets installed on touch screens, fish finders, GPSs, workout machines, displays, really bright displays where you don't really notice that color. It also gets used a lot in aircraft transparency. So this is on the windows of the plane, where they want the pilots to have good visibility. It gets used in those applications quite a bit. And then our OptiView, again, this is typically laminated, so you have a Surface 1, Surface 4 application, but this gets a lot of use in stadiums and arenas and press boxes, anywhere where you're trying to sell merchandise, or the storefronts, museums, zoo applications. And we just brought a product over from Germany, which is OptiView on 12 mil. We've not been able to make that in Laurinburg before, but most zoos and aquariums tend to have like 5 pieces of half-inch glass laminated together. And if you can put an anti-reflective on surface 1 and on surface 12 or whatever that is, there's a lot of reasons that people might want to do that as well. Refrigerator doors, this is done in Europe a lot. North America, we don't have a lot of customers that do that. Touch panels, showrooms, high-end houses and high-rises, homes in Florida that are on the ocean, banks, other commercial buildings, but it gets used in tons of different applications. That's it. Hopefully it's a fairly high-level overview. Anything that I missed, Kayla?
Nothing I could think of.
Awesome.
Thanks for putting this together, Kyle.
Yeah, absolutely. I'm going to go ahead and end the slideshow. We're going to get moving on. Thanks again. Take care.